In the final lesson of this chapter, I want to discuss how to find an inverse function algebraically. That is not just relying on the graph and trying to plot points, but actually algebraically finding an inverse function, as well as what to do when a function is not one-to-one, so, in the instance in which we would have to restrict the domain so that we would be able to find an inverse function. So let's start with a just general approach to finding inverse functions algebraically. So to find an inverse function, I've already listed out the steps here. The first thing we want to do is we want to check to see if the function is indeed one-to-one. We want to see, is my function one-to-one? And if in the instance that it is not one-to-one, we'll have to restrict the domain so that we can actually come up with an inverse function. Next, we would then want to replace all of our f of x's with y's. And this is more of a notation thing, but this will make our life a little bit easier later. And then we're going to switch all of our x's and our y's, and then we're going to solve for y. And as our final step, we're going to replace all of the y's with the correct notation for an inverse function, that is f inverse of x. And we'll need to check the domain as such. So let's go through these steps. Let's start with this problem here, this function that we have on the right side. Let's find the inverse function there. So the first thing we want to check is the function indeed one-to-one? Well, let's look at the type of function that we have here. This is a linear function. So we're going to have something that looks just like this. It's got a y-intercept of -4. Oops, excuse me, it's going the other way. Y-intercept of -4, slope, a y-intercept of -9, and a slope of -4. So this is a linear function, which ensures that all outputs correspond with exactly one input. And again, as a reminder, we can check to see if a function is one-to-one by seeing whether or not it passes the horizontal line test. And we see here that it does. So we can say, yes, this function is indeed one-to-one because it is a linear function. All linear functions would be one-to-one. Okay, so again, one-to-one meaning every output corresponds with exactly one input. Graphically, we can see that using the horizontal line test. All right, the next thing we're going to do is we're going to replace our f of x with y. So we're going to write this as y is equal to -4x minus 9. And now that we've done that, we're going to go ahead and we're going to switch the x and the y's, and we're going to solve now for our new y. So where the y once was, I'm going to write this x. And where the x was, we're going to write a y there. And remember, pardon the pun, but remember why we're doing that. We're doing this because when we're finding an inverse function, we know that the domain and the range of what our function flips around with the domain and range of the inverse function. That is to say, the domain becomes the range of the inverse, and the range of our function becomes the domain of the inverse. And so we know that domain and range corresponds with our x and the y. So we'll just need to switch the x and y. And graphically, we saw this by flipping around the xy coordinates. So now that we've done that, we're going to solve for this y here. We're going to solve for this y. So just by using some algebraic inverse operations, we're going to just write this as -4y. Y then would be equal to -1/4 x minus 9/4. Okay. And as our final step now that we've done that, we're going to rewrite our y in terms using our inverse notation. So you'd say f inverse of x is equal to -1/4 x minus 9/4. So here is our inverse function. And we're just going to check the domain of this inverse function, which in this case wasn't too big of a deal because the domain of our linear function is all real numbers. And the range then would be all real numbers. So let me actually write that. So we'll say the domain of this function here was all real numbers. And the range of this function here was all real numbers. Anything can go in, anything can come out. So if that is the case, what would the domain and range of our inverse be? Well, the range of our original function becomes the domain of this function, so all real numbers. And then the domain of our original function becomes the range of our inverse function, all real numbers. Okay. All right, so let me just go ahead and try one together. Let's go ahead and try this practice problem now. So we're given a function, we're going to find its inverse, and then we'll check the domain and range. It might be a good idea to actually start with the domain and range before we forget. So let's find the domain of f. So the domain of f is as follows. Well, we know it's a radical function, so let me actually do this work on the side. We know that the radicand must be greater than or equal to 0. So 2x is greater than or equal to 4, and x is greater than or equal to 2. So we can say the domain of this function, we must plug in only numbers 2 or greater. Well, what would be the range of this function? Well, if I try plugging in a 2 into this function, I know that the lowest value that comes out of this is 0. 2 minus 2 is 4, minus 4 is 0. And yeah, we know that what comes out of a radical function cannot be negative, right? So we are going to say that the range of this function would be 0. And since the domain can go to positive infinity, the range can also go to positive infinity. All right, so now that we've done that, we're ready to write the inverse function. So first thing we're going to do, we're going to check to see, is my function 1 to 1? Well, f of x is a radical function, so this is a 1 to 1 function. This works because we have a radical function. It is going to pass the horizontal line test. So I'm now going to write y is equal to the square root of 2x minus 4. And then I'm going to now switch the x and the y. So x is equal to root 2y minus 4. And we're going to solve for this y here. So we're going to square both sides. X squared then is equal to 2y minus 4. X squared plus 4 is equal to 2y. And then y is equal to 1/2 x squared plus 2. So here is my function here. Okay, so since this is my function, my inverse function, I would just replace my y with my inverse notation, is 1/2 x squared plus 2. Now ask yourself, what does the domain and range of this inverse function have to be? Well, we would say for this, the domain would be the range of our original function. So the domain would be 0 to infinity. And then the range of this function is the domain of our original f of x. So 2 to positive infinity. Okay? So in closing, I want to do a problem now where I am going to need to restrict the domain in the event that a function is not 1 to 1. So let's go over the directions real quick on what to do, or approach on what to do when our function is not 1 to 1. So we're going to restrict the domain of our function so that it is 1 to 1 and has an inverse function. We're going to find the inverse, and then we're going to state the domain. So first things first, let's look at this function here. And this might be a good idea for us to actually look at this graph here. Okay, so I'm just going to see if I can pull this up. Okay, and let me clear this out of the way. Move this up. Let's clear this out of the way. So let's look at x minus 4. So f of x is x minus 4. Oops, I want to square this. X minus 4 squared. Oops. I promise I'll figure this out. Here we go. All right, so we've got our function here. And actually, you know what? Let me pull up the notes as while I do this so we can see this side by side on the same screen if this will cooperate with us. Okay, here we go. All right, so there's x minus 4 squared. Now, first off, take a look at this graph and ask yourself, is this function 1 to 1? And the answer is no, it is not 1 to 1. Right now, we see that every output does not correspond to exactly one input. For example, if I were to say something like y is equal to 4, taking a look at this graph here, we'd see that when y is equal to 4, for example, this horizontal line intersects this graph at 2 points, which tells us the output of 4 corresponds with 2 different x values, when x is equal to 2 and x is equal to 6. All this to say that this function is not 1 to 1. So now that we know it's not 1 to 1, we need to restrict the domain of this function so that this function is indeed 1 to 1. And in the previous video, we said that the good idea is to kind of split this parabola here down the middle. And we can either choose the part of the function that is to the left of x is equal to 4 or to the right of x is equal to 4. It's really up to you. There's no one approach that's better than the other. So what we can say is the following. Let's go back to this and say, first off, y is equal to x minus 4 squared. If I find the inverse, x is equal to y minus 4 squared. So then if I take the square root of both sides, this left side is the plus or minus root x, and this right side is y minus 4, in which case y is equal to 4 plus or minus root x. Notice we've got two different functions here, and the one that we're going to use will depend on which domain restriction we choose. So In our parabola here, if I go ahead and draw this, let me write this here. We've got, this is 4, and we've got a parabola going this way, and then another parabola going that way. Oops. Let's see if it'll cooperate. All right, that'll work just fine. If I were to choose the part of the graph where x is greater than or equal to 4, where x is greater than or equal to 4, I'm referring to this portion here, okay? Well, then I would choose one of these two inverse equations that I came up with. So I would say the following. If my function, if I'm choosing x minus 4 with a domain restriction where x is greater than or equal to 4, and again, I'm restricting the domain so that I'm choosing just a part of the function so that this will be 1-to-1. So that when I find its inverse, that inverse will indeed be a function. If this is the case, then my inverse would look as follows. This would be, and actually let's move this out of the way, I don't think we need this anymore. This would be 4 plus root x. 4 plus root x. And what would that look like? Well, this would be 4 plus root x. So this would be root x with a vertical shift up 4. So if this is 4 root x, this would be this function here. I'm going to match this up with the purple. In fact, let me go over this so you can see this here as well. Okay, so these two here would be inverses of one another, as you can see. It would look like they are being reflected over the line y equals x. Okay, so it looks like they're being symmetric over the line y equals x. Now suppose instead I had chosen the domain restriction x is less than or equal to 4. Actually, let me actually go back and just do that with my pen, where x is less than or equal to 4. In other words, this part of the parabola here. Well, in this case, I would say the following. I would say, all right, well, I'm choosing the function such that x minus 4, where x is less than or equal to 4. And my inverse for this, then, would be 4 minus root x. 4 minus root x. And what would this look like? Well, it would have the same spot here, vertical shift up 4, but this time I have a minus root x, which would be a reflection over its respective horizontal. So that would look something like this. Oops. If you will. Something like that. Not a great graph, but you get the idea, where it would be symmetric over the line y equals x. So that would be this inverse here, and the purple was this one right over here. Okay. Important to note, you do not need to list both of these. Depending on which domain restriction you choose, you would just need to list one or the other. So if I decided to restrict my domain such that x is greater than or equal to 4, I would just need to write this right over here, along with its original function. If I had chosen my domain restriction where x is less than or equal to 4, then I would write this here, along with its original function. But we need to write the full statement so I know which inverse is going with which restriction. So now that we have that, let's have a quick conversation about the domain and range. So we know that the domain of our function, suppose we went with this one. We would say the domain of f of x was 4 to infinity. Okay? In which case, the range of this function, if we choose 4 to infinity, was 0 to infinity. Again, we're looking at this one right over here. I'll highlight it again, this one right over here. So then, using this information, what's the domain of our inverse? The domain of our inverse would be 0 to infinity, just the range of the previous. And the range of our inverse would be what was previously the domain of our original function, if you will. Okay? So hopefully this helps break down how would we approach a function that is not one-to-one, like we saw in the original parabola. This original parabola was not one-to-one. And then we would restrict the domain either as at x is greater than or equal to 4 or less than or equal to 4, and find its corresponding inverse. And understanding again, to reiterate, that the domain of our original function becomes the range of our inverse, and then vice versa. Go ahead and try this next problem on your own, where it's an absolute value, and hopefully you can see clearly where you'd want to restrict the domain. Hint, it's at -1. That's not really a hint, that's just the answer.